A little algebra throwback lesson today, find and use slopes of lines. Let's just review. How do you find the slope of a line? We remember that slope is rise over run. Rise is the y's, it even rhymes, and run is the x, since that's horizontal on our graphs. So to find the rise, we take the y values and subtract them. To find the run, we take the x values and subtract them. And that is what you know to be your slope formula. Again, just as a little review, we always think about going from left to right when we're talking about slope. And so you'll see that this would be considered a negative slope. This would be considered a positive slope. This would be considered zero slope since there's no rise at all. And then the ultimate slope, where it's just vertical, they call that undefined because technically the slope is infinity, which isn't a real number. Here we've got a graph with 2 points, and we've learned in geometry that 2 points determine a line. And so we should be able to think about a line that goes through those 2 points and what the slope of that line is. Can you first of all tell me if the slope between those 2 points is going to be positive or negative? Hopefully you said negative because we're thinking as we go from left to right, so that would be coming downhill. If you have a nice graph like this, it would be pretty easy just to count the boxes. I could see that I'm coming down 1 box, 2, 3, 4 boxes down for a -4 in rise, and the run is 1, 2, 3, 4, 5, 6, 7 to the right, which I would consider that to be a +7 since it's going to the right. So I could say that my slope is down 4, right 7. I could always write that as -4/7, or some people would even write that as 4 over -7, thinking of that as actually a left 7 and an up 4. The moral of the story is it doesn't matter where the negative sign is positioned. But let's review using the formula too. I would need the coordinates of these points, so it looks like this one's -2, +6. And this one looks like +5, +2. It really doesn't matter which one you consider to be x1, y1 and which one is x2, y2, but maybe it would help you to label them. So if I wanted this to be x1, y1 and this x2, y2, that would work just fine, but it doesn't matter. It's that you're consistent on the top and the bottom of your slope formula. So on the top, I want the rise, which is the y's. I'm going to take y2 minus y1. And then the run on the bottom would be the x2 minus the x1. Getting -4 over 7, which is how we counted that slope too, going down 4 and over 7. You might be wondering, why are we even talking about slope? This is geometry class. Well, we had just been talking a lot about parallel lines. And coming up next, we'll be talking a lot about perpendicular lines. So it's actually true that the slope can tell us a lot about whether you have parallel or perpendicular lines. Slopes of parallel lines will always be the same. And slopes of perpendicular lines will always be opposite reciprocals of one another. So on this little example, if I wanted to make a line that was parallel to my -4/7, I could pick any point on the graph, and as long as I went down 4 and over 7 to the right, that line would be considered parallel because it has the same slope. Now perpendicular, you have to work a little harder at. Perpendicular slopes are going to be opposite reciprocals. So since this one was negative, I'm going to go with positive. And since this one was 4/7, I'm going to go with 7/4. So again, I'll start with just some random point and then use that slope, which is +7, +4, so up 7 and over 4. That should give me a perpendicular line. So one more time, same slope is going to give us parallel lines, and opposite reciprocal slopes give us perpendicular lines. Here we have a good old y equals mx plus b. Mx plus b. Remember that the b stands for the beginning point, or the y-intercept, which is where you want to start. So y-intercept on the y-axis up at 6. And then the slope is -4. If it helps, you could write that slope as -4 over 1 to remind you that the run is 1. So we're going to go down 4 over 1. Down 4 over 1. And you can do that as many times as you feel like doing. But really only 2 points are needed to make a line. And there we've got the line y equals -4x plus 6. Our instructions are to give an equation for a line that's parallel to that one. What do we know about parallel lines? We know that their slopes have to be the same. So on this one, I know I'm going to also use a slope of -4. As far as where it intersects the y-axis, I can really choose any number I want to. Maybe I'll just choose the number 1 just for funsies. So that would give me an equation of y equals -4x plus 1. Let's graph that one. That looks nice and parallel to me. Let's go for a perpendicular line this time. Since the slope of the original one was -4 over 1, I'm going to want to use the opposite reciprocal of that. So I'll want to use a positive slope, and the reciprocal would be 1 over 4. Again, it doesn't really matter what I choose for my b value. Maybe I'll just go with -2 this time. Just picking any random number I want. So I'm going to graph the line y equals 1/4 x minus 2. Doesn't that look nice and perpendicular to my original line? So again, we use the slopes to determine whether we have parallel or perpendicular lines.